We know that an object traveling at a constant speed in a straight line will always remain in its straight direction if there is no interference. If the body m is attracted by force Fa from point A, it will orbit around point A. We have assumed that Fa corresponds to the centrifugal force of the body of small fa. If the body m is attracted by force Fb from point B, it will orbit around point B. We have assumed that Fb corresponds to the centrifugal force of the body small fb. If these two external forces together attract the body, it will resist both centrifugal forces and will orbit approximately on a c-plane. Because the two external forces act perpendicular to the direction of motion, the speed of the body has not changed. The distances between the body and the two forces also remain unchanged at this position. Therefore, the intensities of the forces to the body as well as the resulting centrifugal forces have not changed. Only the position and shape of the circle have changed. The radius r was the radius of the circular motion. Now the radius L, we still call it the radius, is the distance from it to the external force, which is no longer the center of the circular motion, but can also be. Otherwise, this change has no influence on the basic principle of centrifugal force. To get a better overview, we align the line AB vertically. This places the C-plane on a horizontal plane. Now we ask a simple question: what is the horizontal centrifugal acceleration AZ? The answer from our previous knowledge of physics, as we learned it at school, is beyond doubt. Probably nobody would expect this answer to be wrong. In reality, the horizontal acceleration AZ is a superposition of two components of these two true centrifugal accelerations AA and AB. Therefore, the actual acceleration AZ must be as follows. An interesting equation results from the formulae, asterisk, and, double asterisks. These ratios mean that in a state of equilibrium, for example, the terms AALA and LBLB can be exchanged for each other. This does not disturb the equilibrium. To simplify, we draw a line Y that runs through the object and is perpendicular to LA. Let the components of FB and FB on Y be F3 and F3 respectively. We can assume that F3 has an imaginary distance L3. However, we do not need to worry about how long L3 actually is, but they have the same ratio as below. And from centrifugal force Fa we also have the same ratio. From this there is we can replace A3L3 by AALA, i.e. F3 by Fa, without affecting the equilibrium of the motion. In this situation, F3LA is a downward pulling torque and FALA is an upward pulling torque. The two compensate each other in a dynamic equilibrium. This means that F3, which could be a component of several forces, is equal to Fa. The centrifugal force AZ can then be expressed by the superposition of the two components of two orthogonal forces of equal magnitude. We can now use a conical pendulum as an example to determine the true magnitude of a typical centrifugal force. As already mentioned, AZ is here the superposition of the components of these two AA, and not, as previously assumed, that these two AA are the components of AZ in these two directions. It seems to be only a small conceptual difference, but the results that arise from this would be completely different. So the correct answer is as shown. From the following equations, results in the following. Compare with the previous incorrect formula. To explain the extended centrifugal force in more detail, let's take another example of a school physics problem about this conical pendulum, where you have to calculate how strong the tensioning force of the rope is. So far, this has been solved as follows. This solution is obviously wrong, because if the speed continues to increase and the angle theta is increased to 90, the rope tension would be infinitely large, which does not correspond to reality. It is unbelievable that there can be such a stupid mistake in our physics. The error clearly lies in the fact that the two forces Fa and Fb have so far been wrongly assumed to be the components of Fz in these two directions. In reality, Fz is the superposition of the components of these two Fa and Fb. As already explained, the centrifugal force Fa is a real force. The rope tension is therefore simply as follows. Because Fa is equal to Fb, the cable tension can also be expressed as follows. Note, this expression can only be used if theta is less than 90 degrees. If the speed continues to increase after the angle theta has been increased to 90 degrees, the centrifugal force Fa also continues to increase and with it the rope tension. However, the angle never becomes greater than 90 degrees. This is another property of centrifugal force. The magnitude of the centrifugal force of an object against an external force is always equal to the magnitude of this force. This property is also similar to Newton's law of action and reaction. But the maximum is: if the external force is greater than the centrifugal force, the object can no longer maintain its original state of motion. Extended centrifugal force is understood to mean the centrifugal force counteracts all external forces that are perpendicular to the direction of movement of the object. The centrifugal force depends only on the distance of the corresponding external force and the speed of the object. It is independent of the shape of its circular motion. The strength of the centrifugal force is always equal to the strength of the external force acting on the object, but is the maximum. The radius r is the distance between the object and the external force, not always the distance between the object and the center of the circle.
Thank you very much for your attention. See you next time.